Hello and welcome to this video about potential difference, and we are going to talk about what is potential difference and how we calculate potential difference in different circumstances. Potential difference is simply a change in electrical potential energy. We think about it mathematically like this, and you can see that the change in the potential difference, delta V, is equal to the change in electrical potential energy divided by the charge. If you'll notice, a greater charge is going to involve a greater amount of electrical potential energy. And so this ratio right here is going to be the same as it would be if a smaller charge were at the same position. We'd have a smaller amount of electrical potential energy. So in other words, the electric potential at a point is independent of the charge at that point. Also note, the SI unit for potential difference, or it's also called electrical potential, is the volt, symbolized by a capital V. 1 volt is equal to 1 joule per coulomb. Realize that electrical potential energy is a quantity of energy measured in joules, and potential difference measures energy per unit charge, and that's what a volt is. If you're a little bit confused about the difference between potential difference and electric potential, let me define that real quick. V will represent simply electric potential. And if we think about just electric potential rather than the change in electric potential, that is going to be equal to just the potential energy divided by the charge, not the change in it. However, the reference point for measuring potential energy, electrical potential energy, is arbitrary. And since the reference point for the electrical potential energy is arbitrary, that means also the reference point for the electric potential is going to be arbitrary. Therefore, we write the change in the electric potential is called the potential difference. The change in the electrical potential energy is just called the change in electrical potential energy. And that would be the difference between those two. Well, you oftentimes just use those interchangeably. The potential difference is then the change in the electrical potential. So when we look at something like this battery, we're talking about the change in the electrical potential between these two terminals. For this battery, it's 12 volts. Some batteries, it's less than that. In this wall outlet, the change in electrical potential between these two slots is 120 volts. Let's think about the electrical potential energy of a charge in a uniform electric field. If we do that, we can combine the expression for potential difference with the expression for electrical potential energy. And I'll just spare you the math on that. You can combine those and come up with derive the same equation, but this is the equation that's derived from that. That the potential difference is equal to the negative of the magnitude of the electric field times the change in displacement. For this equation, delta D is the displacement moved in the direction of the magnetic field. Any displacement that is perpendicular to the field will not change the electrical potential energy. Now let's look at another situation. Let's look at the potential difference between a point at infinity, some point, and a point near a point charge. Now, I'm not going to go through all of the deriving of this equation to save you some time. You can derive that from all the equations that we have. However, this equation represents the potential difference being equal to our Coulomb constant times the value of the point charge divided by the distance to that point charge. Realize that even though our electric potential the value of the electric potential depends on the value of the point charge, still an electrical potential does exist at any point in an electric field regardless of whether there is a charge at that point. We can also use the superposition principle to calculate the electrical potential for a group of charges. So let's look at an example together to work through some of these equations or work with them. A 5.0 microcoulomb point charge is at the origin, right here on the diagram, and a point charge of negative 2.0 microcoulomb is on the x-axis at 3 meters and 0.0 meters, right? It's shown right here. Find the total potential difference resulting from these charges between P, point P, which is up here, and its coordinates are 0.0 and 4.0, and that's shown on the diagram, and a point infinitely far away. Let's write down what we know. Charge 1 and charge 2, I went ahead and converted those into coulombs. I also know the distance between Q1 and P, and I'm calling that R1. It's 4.0 meters. I can find R2 by simply using my Pythagorean theorem, because I also know that the length right here is 3 meters. So I can find R2, and I come up with 5.0 meters for R2. I'm going to use my equation for the potential difference near a point charge, and I'm going to look at the potential difference for a point charge concerning charge 1. So I'll call that my potential difference 1, because I'm going to talk about just point charge 1, Q1. I'm going to substitute my values in for R1 and for charge on 1, and also the Coulomb constant. And I get 1.1 times 10 to the 4th volts for my potential difference 1. To find the potential difference 2, I'm going to look at the Coulomb constant times charge on 2 divided by R2 and plug those values in. And when I do that, I get negative 0.36 times 10 to the 4th volts for my electric potential 2. Now, to find the total change in the total potential difference, I'm going to add these two together. And sorry, I ran out of room. I'm going to write that over here. That's my equation for finding the potential difference, the total potential difference. So when I plug those values in, this is what I get. I should put parentheses around that. And remember, here we have the minus sign because this is negative. And I get now for my potential difference 7,000 volts. And last but not least, a battery does work to make charges move. That's kind of tying in the idea of work with all of the ideas with electricity that we're learning right now. Advanced idea, compare and contrast the cost of alkaline batteries and rechargeable batteries with how long they last. Or maybe you have some other ideas to look into. I look forward to seeing what you come up with, and we'll see you in class.